Hello, everyone. I'm William Xiong. I'm from openEuler community. Here, I will give a presentation of openEuler. I'm very happy to give the talk in Linaro Summit. My topic is innovation drives the future of openEuler. It's the first time for openEuler to present in Linaro Summit, and I will do a rough introduction of what openEuler is and why we build openEuler project. And I will give some introduction of projects openEuler have. And finally, welcome to anyone to join into the openEuler. And I believe openEuler can work with Linaro together to build the 64 ecosystem together. Okay, first one is why openEuler. There are a lot of OS community of the world. Why we build another community? I think there are several reasons. The first one is we need to make new technology and features more accessible to the end user. And secondly, we want to provide a unified platform to support the system and ecosystem from IoT to the cloud. And the third one is we want to do some exploration of to change the OS platform to make the OS maybe easier and more secure to do some research job. Okay, let's move on to the reason one. We want to deliver a new feature to end user faster and easier. If we want to release some chipset, after the chipset is released, we have to provide the patches or features to the upstream community. And after those features and the patches accepted or merged by the community, and the OSV will pull them down and integrate into their release. So this is the regular process. But during those process, it may last several months or even over 1 year. It's not short time. For OSV, the commercial OS vendor, I think it's reasonable because OSV need to make sure the product is stable enough. But can we make things better to improve this? Okay, let's check out how openEuler make the try. How we want to try to fix the issue. openEuler has a mainline, and we have two kind of version. The first one is the first release is we call it a community release or innovation release. The second one is we will provide RTS release based on the innovation release. RTS means long-term service support. For the community release, we will release twice per year. And the community release will sustain for 1 year. And for the RTS version, we will release the RTS release per 2 year. So we can, the first release is, the RTS release is in this year, and the next release will be the 2022. And for the RTS version release, we will maintain for 6 years. So I think it's a time longer enough for the commercial users. And for the OSV, we hope the OSV can produce their product based on the RTS. This is the regular roadmap, and from the roadmap you can see, it's not easy to develop OS, especially for the commercial OS. So that is why we want to make the OS development more easier. especially for the ARM64 ecosystem. And the second one is OpenEuler is more aggressive in technology and release policy. We will have more. The first one is we will have more aggressive release cycle. So you will track for the last page I gave out the release cycle. You can see we will release the LTS per 2 year. So that cycle will the OpenEuler easily to use the latest kernel. We can catch up the latest community release to keep sync up with the latest upstream. So that will help our customer to adopt the new technology. And the second rule is upstream first. Anything we have done will contribute to the upstream community first. But if some feature or patches are not easy be accepted for the upstream community, we are quite open to those new features. So we will keep the balance between the quality and the technology risk. So that is the two main things we want to focus. Okay, let's move on to the reason 2. ARM is used from IoT to cloud, but the OS is not. ARM is dominant in the IoT or edge computing or something like that, the embedded system. And ARM is moving to the cloud quickly. But the OS vendor is quite different. For the embedded system, we have some OS vendor, for example, the vendor company. And for the server industry, we have CentOS, Red Hat, SUSE, or Ubuntu, or something like that. That's quite different. So is it impossible for us to build a unified platform to meet all of those kind of scenarios? If we don't have this kind of platform for developers, although they build an application for ARM, but a different OS will still have a lot of difference. So it's not easy for the developer to migrate between the different OS. So our idea is we worked with OSV together to build a unified OS base. In China, we have worked with several major players in OS, and we work together to define what OpenEuler should be like and what OpenEuler, the interface need to provide, and we unify the interface. So all of the OSV will produce their commercial product based on OpenEuler. So that means for the end user or developer, although they may use different product, the commercial product, but they share the same interface and share the same environment. So it's simplify the development and usage for the end user. So I'm very happy that this job is working on the progress, and those OSV, they are very we work together very well. And secondly, I think we need a solution that can help IoT and cloud to share the same infrastructure. For the system, IT system, we need to virtualization and container. Those two parts are the major part of the IT base. So for the virtualization, we start a project named Stratword. This is a totally new virtualization platform. It's similar as Qumio, but we use Rust language to rewrite the whole system and remove a lot of unnecessary part of Qumio and keep the Stratword to be light and faster. And for the container, we develop a project named iSula. it's also used the language as C and Rust to rewrite the container environment. Also, the target is to make the system to be light and faster and secure. So if we have this kind of two software, we can provide a unified IT base from IoT to edge computing or even cloud. And all of those software will conform to the industry standard. For example, for iSula, we conform to the OCI container standard, and we also conform to the CRI standard. So that means if we want to integrate iSula into the cloud native or Kubernetes environment, it's very easy. Okay, we have released iSula in openEuler community, and we will release a StratoVert by the end of this month. So okay, welcome anyone to check them out and make some try. Okay, for the reason 3, we need to make OS easier to use. Generally speaking, IT infrastructure is complicated. It's not easy to upgrade, optimize, and make the system secure. So openEuler provide some tools to help to make those difficulties to be easier? So that is, I think, a very interesting topic we want to discuss in the community. Okay, let's, for the openEuler community, we welcome any idea. Until now, we will focus on 3 directions. The first one is secure. The second one is the cloud native. The third one is, we want to make things to be easy to use. So if you have any idea which can help us to reach those goals, we will very welcome. Let's move on to the first one, the security. For security, we have several projects, and the first one we will release by the end of this month is the CloudEnclave. CloudEnclave is designed to meet the requirement of confidential computing. Confidential computing is more and more popular in the industry, and but the problem for the confidential computing is it's not easy. It's very difficult to develop this kind of software. So CloudEnclave provide a middleware to simplify those jobs. The whole software is divided into 3 layers. The bottom layer is the base layer. The base layer, cover the different hardware, the difference between among the different hardware facilities. For the confidential computing, different hardware vendors provide a quite different, mechanism. Intel provide SGX, ARM provide a trust zone, and RISC-V maybe have the Keystone. So if you want to develop some software, you need to, to handle different SDKs, different interfaces. So the base layer will cover those differences. The middle layer will have an abstraction interface to help the customer to easily develop software. And on top of these 2 layers, there are the service layer. The service layer will to provide some service interface to make the customer easily to develop different service. For example, based on CloudEnclave, you can develop the KMS service very easily on top of trust zone. And also you can to build the blockchain service. You can provide the secure database service or something like that. We provide the very easily used interface. So there are two targets. The first one is we want to build a unified and easy to use interfaces for the application developer. The second one is we want to isolate developer from complicated hardware details and handle the different SDKs. So by the end of this month, we will put the code on the openEuler community. So welcome anyone to check them out and to develop the confidential computing based on CloudEnclave. Okay, let's move on. The second one direction is the cloud native OS. You know, until now, all of the OS is composed by RPM or the DEB Debian packages. So OS is composed by thousands of different kind of RPMs, but RPM is not easy to manage. It's not easy to upgrade, downgrade, or something like that. So we can bring the idea from container. So is it possible for us to put OS itself into a container image? So if we can do so, we can imagine when we want to upgrade OS, it means just replace a container image other than yum install a lot of software, RPMs, to make the system easier to maintain. So this is the first thing we want to do. The second one is there are a lot of system service, system daemon on Linux system. But if we consider the system running in the cloud, in the cloud native scenario, we have a lot of network, the cloud service we can use. We do not need to put everything on the OS service. For example, a lot of cloud environment provide a log service. And also OS has its own log service. Can we offload the local log service to the cloud? This is a very interesting question. And in the same way, can we offload the audit service to the cloud? So no matter we put the OS into a container or we offload some system service to the cloud, the total idea is we want to make the OS simpler than complicated. So that's a very interesting topic we want to discuss in the future. And we are working on some prototype, and we hope we can release the prototype in next year. So if anyone get interested in this direction, we welcome join into the community. We discuss together. Okay, let's move on to the easy to use. One of openEuler's target is we want you to try to make the OS to be easy to use. Here, we set up a project named ATune. The target is to make the performance tuning easier. When the application vendors, they want to use the OS, the software from the OS to the application will be the software stack is very heavy. It includes maybe the database, the middleware, the applications. So the performance tuning will be a very hard job. It needs very professional engineer to do so and spend a lot of time. So can we provide some tools to simplify this job? Here we provide we make a try, we build the software ATune. It's an AI-based tuning job. It help the customer, the developer to modeling, to build the model of your system, and to do some AI tuning job, and to collect the information and to do the analysis and give some suggestion for the parameters value or something like that. We do some tests on different scenario. For example, the database, the web service, the big data, or something like that. The different scenario will have gain different result. In some scenario, we can get a very good result. The performance can be increased over 50% over one night. We deploy the software in the environment and run at the night, and in the morning we can get a result. It save a lot of human beings' labor. Okay, this is the AI tuning tool. Okay, it's very close to the end of the speech, and finally, welcome to join the openEuler community. The process is very simple. Just sign the CRA and to join the SIG, the special interest group. We have over 70 SIGs until now. It covers different parts of the OS. And in the community, you can assign issue to file issue. You can get the build and the development environment, and you can contribute the code and review code and to take part in the community activities and something like that. So the community is very open to anyone, to any company, to any developers or something like that. Okay, here is the address, the URL. You can check the address and to find out the code, to find out the documents, and to join the community. If you have any problem, we welcome to discuss in the community. And finally, openEuler will work with the Linaro. We have set up the links, and also I think we both sides can work together to promote the ARM64 ecosystem. That is the very, very important target for the openEuler community. I think we share the same target for the both parts. Okay, thank you. Here is the end of the speech. So finally, welcome to openEuler, and we are eager to work with Linaro together to build the ARM ecosystem. Welcome to any suggestion, the issue, or any development work. Okay, thank you. Bye-bye.